Okie dokie. Welcome back. 7.4 systems of nonlinear equations in two variables. Yeah, my cat just got back from the vet. So you were probably familiar with the two equations, two unknowns, three. You probably handled that. Maybe even saw the three equations, three unknowns. But you're probably not as familiar with the nonlinear equations and two variables. And it's probably more likely that if you keep taking math that this is the kind of thing you're going to be up against. And every once in a while, I'll come across one. I just came across one in Calc 3, like last semester, that kind of threw me for a loop. Um, and I'll try to give you a good method, a good basic method for handling these problems. But at the end of the day, again, it's going to come down to keep your wits about you. Think for yourself, basic sort of thing. And okay, so anyways, section 1, substitution method. And just as before, I'm going to advise you to avoid fractions and also avoid roots. Okay. So avoid fractions. And also avoid square roots. So the problem with roots is you'll introduce this plus or minus thing floating around all the time. It'll get really annoying really quick. So just avoid them like the plague. Okay, so anyways, let's look at number 3. And we have a nonlinear system, x plus y equals 2, and then y equals x squared minus 4x plus 4. Geometrically, what you're looking at here is the equation of a line and the equation of a parabola. So, not knowing what exactly we have here, there's 3 possibilities. There could be 2 solutions. There could be just 1 solution. Maybe it hits like this. And there could also be 0 solutions, of course. Okay? So the line just completely misses the parabola. Sadly, if these formulas get complicated enough, odds are you're not going to have that geometry in mind, and you're just sort of left with your algebra. And so, anyways, let's go ahead and tackle this problem. So I'm going to avoid kind of anything. Trying to solve for this x right here is going to be a real annoyance. The y is already solved for, so you could do a substitution there. And go. So let's try that. So first, I have one equation's already solved for one of the unknowns. And then secondly, take that expression and substitute it into the unused equation. So you'll have x plus, so I'm taking this equation here, I'll have x plus this new expression, x squared minus 4x plus 4 equals 2. And then you can solve this. So this is a quadratic equation. We'll have combine like terms. So x squared minus 3x plus 4 is 2. Set it equal to 0. So you have x squared minus 3x plus 2 is 0. And then hopefully you can factor it. You don't need to do the quadratic stuff, quadratic formula or anything. Okay, so you'll have x minus 2 and x minus 1. And so it looks like we're going to end up with 2 solutions here, x equals 2 and then x equals 1. So we'll take these guys now in step 3, back substitute each one into this formula for y. You can also solve this for y and then put them both in here, and that'll give you the answers as well. Okay, it's up to you what you want to do. I'm just going to go with, just to be consistent, I'm just always going to go to this first equation. Looks like I need a little more room. So step 3, y equals x squared minus 4x plus 4. I'll start with x is 2, so y will equal 4. 2 squared is 4, minus 4 times 2 is 8, plus 4. 4 plus 4 is 8, and so y is 0 when x is 2. So we get our first solution, 2, 0. And then substitute in x equals 1. So you'll get y equals 1 squared is 1, minus 4 times 1 is 4, and then plus 4. 4's cancel, and you get y is 1. Okay. So the other ordered pair, 1 comma 1. All right, it's pretty simple, but you can get into trouble. You want to, like I said, avoid these fractions, avoid the roots. And in number 7, that's kind of an issue. So let's explore 7. I have x squared plus y squared is 25, and then x minus y is 1. Okay. So again, you want to avoid solving this equation for x squared or y squared. And very quickly, if you tried that, you would get 2 expressions for substitution, okay? And you don't want to have to do that. I mean, you can, but working with roots is always kind of annoying, and we'll try to avoid that. It's just, it'll complicate things, and I mean, sometimes there's no way around it. You just have to do what you have to do. But if you can avoid complications at this stage in the game, it's better just to keep it simple, unless you're looking to become a mathematician or something. Just don't worry about it. So simply put, first step, I'm going to solve x minus y is 1. So I'll get x equals 1 plus y. And then step 2, I'm going to take that expression and put it into this equation here, which is the equation of a circle with radius 5, by the way. So anyways, you're putting in 1 plus y squared plus y squared equals 25. Okay, and then we're going to FOIL that add the y squared. So we'll get 1 plus, there's going to be y plus y, so 2y plus y squared equals 25. Okay. And that's a quadratic form, so I'm going to combine like terms and set it equal to 0. So 2y squares plus 2y. And if you subtract 25 to the other side, you're going to get minus 24 equals 0. Make life easy on yourself by factoring out or multiplying both sides by 1/2 is another way to think of it. So let's do that. Multiply both sides by 1/2. Okay. Inside here, if you distribute through, you get y squared plus y minus 12 equals 0. And then you can factor this guy. So you get y plus 4, and then y minus 3 is 0. And then get your solutions. So you have y is -4 or y is 3. Okay, finally then, step 3, we're going to substitute back into, and literally again, you can use either equation, but we're going to use this guy here, the x minus y is 1. Okay, so I'll have x, well, let's try y is -4, right? So you'll have x minus -4 is 1. So x plus 4 is, oops, I meant to use this equation, but I ended up using this. No big deal. So x is going to be -3. And then over here, we have x, the other guy is +3, so x minus 3 is 1, so x is 4. And then our ordered pairs, -3, comma, -4. And then the other one, when y was 3, we have 4, comma 3, okay, for our solutions. Okay. Just for the sake of curiosity, let's see what would happen if we would put these guys back into this equation here. So if I was using x squared plus y squared equals 25, and I'm plugging in y equals -4, what would happen, right? So I get x squared plus -4 squared is 25. I get x squared plus 16 is 25. So x squared equals 25 minus 16 is 9. And then x equals plus or minus 3. So this thing, it doesn't work, you know, and that's kind of scary. You know, you wouldn't know any better doing your homework. You're just sitting there doing your homework and you do this and you think it's going to work and it doesn't. So, you know, it's you got to be careful. And the only expertise I can give you is to avoid those square functions. Work with the simple ones as much as you can and sort of avoid these guys. If you're ever stuck in a case where your life depends on you being able to solve something like this, check your solutions in the original equations. So certainly I'm sure x -3 comma -4 works, but then what was the other solution? 3 comma -4 from this work. So if we plug this into each equation, it'll work in the first one, right? So 9 plus 16 is 25. That's going to be a true statement. 25 is 25. So if I plugged it into there, it worked. But if I plug it into the x minus y is 1, it's not going to work. So you'll have 3 minus -4 is 1, and then 3 plus 4 is not 1. So you would be able to throw out this solution as not valid. Right? Okay, so you know, if I guess when you're beginning, the way I'm doing it, it's usually going to work. So, but for you as a student, when you're first beginning, you're probably going to have to check those solutions and make sure they work. It's kind of time consuming. But anyways, there's our solution. Let's move on to the next one. We beat that to death. Number 13. Right, so we have xy is 3, and then x squared plus y squared is 10. So step 1, I'm going to solve this equation just for the sake of the fact that I hate dealing with roots, and I hate dealing with these kind of equations. Okay? So I solve the first one for whichever variable you want. I'm going to solve for x. And then I'm going to substitute this into the unused equation. And just to the side, if you get y equals 0 as a solution, it's automatically not going to work, right? So, I mean, if you try to put y equals 0 into this equation, you're going to get 0 equals 3, which is false. So therefore, it's not a solution anyways. So, you know, square root 10, maybe you're thinking works in here, square root 10 comma 0, but it won't work in this guy. So there's actually 2 solutions associated with 0 that just will work in this guy, but not in this guy. Okay, but I mean, I'm just saying that for your future. If you take more classes, it's not going to be a big thing here, though. So anyways, take this guy and substitute it into there. So we'll have 3 over y squared plus y squared is 10. I'm going to solve this thing, and I hate fractions, right? So I'm going to get rid of this y squared. By multiplying, I'm going to get rid of this fraction. So what is the fraction right now? It's 9 over y squared. I'm going to get rid of that problem by multiplying both sides by y squared. Okay. So over here, you can distribute. The y squares will cancel on that one. But then you get y squared times y squared, which is y to the 4th. It's 10y squared. And then that has kind of a quadratic form. So you're going to move everything to one side. So I'll have y to the fourth minus 10y squared plus 9 is 0. And then factor that guy. So you'll get y squared. Y squared is 0. And then you're looking at what? So 9 and 1 minus 9. Okay, so you get y is plus or minus 1, and then y is plus or minus 3. Okay. So step 3, we need to sort of substitute these guys in somewhere. Y equals plus minus 1. Y equals plus minus 3. So for y equals 1, x will equal 3 over 1, which is 3. When y is negative 1, x will equal 3 over negative 1, which is negative 3. Over here, when y is equal to 3, x will be 3 over 3, which is 1. And then when y is equal to negative 3, x will be 3 over negative 3, which equals negative 1. Okay, so in this case, we have 4 solutions. And if you think about what these graphs are, this guy is a rational function. So something like this, and then this guy's a circle. Okay, so it's probably going to have 4 solutions, assuming these are solutions. I'm not going to bother checking. I know they are. Okay, so what do we have? 3, comma 1, comma negative 3, comma negative 1, comma 1, comma 3, and then comma negative 1, negative 3. Okay. And you could do some spot checks. 3 times 1 is 3. That works here. Negative 3 times negative 1 is 3. 1 times 3 is 3, and that one's also 3. And then when you plug them in here, you get 9 plus 1 is 10. 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 Okay, so these all work. I think the only fear is maybe I missed one, right? Did I get them all? I don't know. Well, I hope so. Geometrically, it seems like there can't be more, okay, unless some weird phenomena is going on. I don't think there's any more. Okay, number 17, let's take a look at that guy. So we have x plus y is 1. And then we have x minus 1 squared plus y plus 1, sorry, y plus 2 squared is 10. Okay. And again, I'm going to sort of avoid this guy, using it to find solutions unless I have to. So the substitution, I'm not going to solve this equation. I'm going to be solving this equation here. So I'm working with the x plus y is 1. And then I'll have x equals 1 minus y. Okay. Then secondly, take this expression and substitute into the unused equation. So we'll have 1 minus y minus 1 squared plus y plus 2 squared is 10. And so we have 1 minus 1 is just 0, so negative y squared plus this thing, I'm going to FOIL it. Get y squared plus 4y plus 4 equals 10. And then negative y squared is y squared plus y squared plus 4y plus 4 is 10. It's quadratic, so we want to set it equal to 0. We got 2y squared plus 4y plus, move the 10 over, and you get negative 6, 0. Multiply both sides by 1/2. And I'm getting y squared plus 2y minus 3 is 0. And then we could easily factor that into y plus 3 times y minus 1 is 0. And so y is negative 3, and then y is 1. Okay. So we take these solutions now and pump them back into here. Okay. So step 3, y is negative 3. I'm going to go x is 1 minus negative 3. So that's going to be 1 plus 3. And then if y is 1, I get x equals 1 minus 1. In other words, x is 0. Sorry. And so our solutions, looks like we have, this one's 4 by the way, 4 comma negative 3, and then 0 comma 1. Okay, you can do a quick spot check on these. 4 negative 3, 4 plus negative 3 is definitely going to be 1. 0 plus 1 is definitely 1. 4 minus 1 is 3. 3 squared is 9. Okay, plus negative 3 plus 2 is negative 1. Negative 1 squared is 1. So 9 plus 1 is 10. And so both guys will work. Okay, let's move on to the other method. So this was the substitution method, of course. And just like working with linear equations and two unknowns, there's also going to be the addition method. And so we have number 19. Let's take a look. We have x squared plus y squared equals 13, and then x squared minus y squared is 5. Right? So when they have a nice alignment like this and you look column-wise and there's a cancellation, it's a good idea to go ahead and just use the addition method. So here, automatically I have the y squares canceling, so I'll just have 2x squares equals 18. And then we solve this equation, divide both sides by 2. So x squared is 9, and then take the square root of both sides. X is plus or minus 3. Okay. So then we substitute it into either equation that has both variables. So I'm looking at x equals negative 3. I have 9 plus y squared is 13. Move the 9 to the other side. So I have y squared is 4. And then y is plus or minus 2. Okay, so we get two solutions there, negative 3 comma 2, negative 3 comma negative 2. Okay. Then with the number positive 3, plugging that in, we get 9 plus y squared again is 13. And so we're going to get y equals plus or minus 2 again. Right? So 3 comma 2, and then 3 comma negative 2. Right? And you could kind of visually check that again. You're always going to get 3 and 2 resulting, and all this is just the complete variation of plus plus, minus plus, plus minus, and then minus minus on the numbers 3 and 2. Okay? And it works because these guys are squared, and whatever the sign is, it's going to go away and become positive, and then this will work. So for instance, negative 3 squared is 9, minus negative 2 squared is 4. So you end up with 9 minus 4, which is 5. So those all work. 27, let's take a look at that guy. Y squared minus x is 4, and then x squared plus y squared is 4. So I'm going to solve for this variable here. Again, it's just to avoid roots. So first, I take this equation and solve for x. So I get x is y squared minus 4. And then I take that expression and substitute it into the unused equation. So I have y squared minus 4 squared plus y squared is 4. And then solve that. So I have the FOIL here. Y to the 4th minus 8y squared plus 16 plus y squared is 4. Set it equal to 0. Get y to the 4th minus now 7y squared plus 12 is 0. And then that's easily factorable. I hope it is. Y squared minus 4 and 3. 4 y squared minus 3 is 0. And square root property on both of them. you get y squared minus 4 is 0, so y squared is 4, and square root property says y is plus or minus 2. From the y squared minus 3, you get y squared is 3, so from the square root property, y is plus or minus root 3. Okay. I'll get this pen out of the way before they all start falling. Yeah. Step 3 then, do your back substitutions. So when y is 2, I get x is 4 minus 4, which is 0. When y is negative 2, I should get the same thing. X is negative 2 squared minus 4, which of course is 4 minus 4, which of course again is trying to rotate this thing, and I don't want to rotate. There we go. 4 minus 4, which is 0. So 2 solutions there. 0, negative 2, and then 0, 2. Over here then we get y is radical 3, so x is radical 3 squared is 3 minus 4, so negative 1 root 3. And then the last guy, y equals negative root 3, and you get the same deal happening. The square of a negative is positive, so the square of negative root 3 is 3 minus 4, and negative 1 again. So our fourth final solution, negative 1 comma negative radical 3, and that's it. And you can spot check these, make sure they work. 0 and 2. So I got 0 plus negative or positive 2 squared is going to be 4. So 0, it'll work in here. Putting them in here, plus or minus 2 isn't going to affect it because you had that y squared. So whatever plus or minus 2 you put in there, it's going to be 4. And then you subtract away 0, you're going to get 4. Radical 3 squared is going to be 3. And then minus negative 1 is going to be 4. They're going to work. Okay? You sort of get a jive for it. And yeah, that's going to work. All right, let's look at some applications and just one geometry application. So section 3, apps. We have number 62 on page 852. And they tell us some information. I guess they're trying to build a box for the holidays. You know, you have to buy those boxes to put your presents in or whatever. There we go. So in this case, they're giving us area and the volume. So the box looks like this. It's made out of a piece of board, cardboard or whatever, and the area is 216 inches squared. Okay, we're going to call this side W and then call this side L. Then to make the box, they take that piece of cardboard and cut out the corners so you can fold up the sides and have your box. Okay. So the corners each is 2 inches in. Okay. And then finally they fold up the box, and the box then has a volume associated with it, which they tell you. The volume is 224 cubic inches. Right? All right, so we need to create a system of nonlinear equations based off this information in order to solve for W and L. So the first equation is that W times L, the area of this box is 216. Okay. Then we want a formula for the volume. So the sides right here and right here are based off of these sides right here and right here. Okay. So to find these sides, you're subtracting 1, 2, 3, 4 from these sides over here. So this side here should be L minus the 1, 2, 3, 4. And then this side over here should be W minus 4. Okay. So on the box here, this side, this front, you could say is W minus 4. This side here, L minus 4. And then the height of the box is just going to be 2. Right? This corner right here. And when they cut it out, it's 2. So when you fold it up, it'll be a height of 2 inches. Okay? So the volume of this box is just length times width, or width times length times height. So you'll have W minus 4 times L minus 4 times 2 equals 224. Okay? So we want to probably multiply that out. I don't know if it's even necessary. We could solve for W and L and then put it into here, and maybe it'll be easier, but I don't know. Let's simplify it. Okay. So WL is 216. Down here I got a FOIL and then distribute. So I got 2 times WL minus 4W minus 4L plus 16 equals 224. And then I got, what do I got? 2WL minus 4W minus 4L plus 16 equals 224. Okay. So first, I'm gonna do the substitution method and see what happens. So first, I'm going to solve this equation for one of the unknowns. So WL equals 216. L will then equal 216 over W. And then I'm just going to substitute that into the other equation and see what happens. Okay, so here we go. Step 2. I'm going 2 times W times L is 216 over W minus 4W minus 4 times 216 over W plus 16 equals 224. Now maybe I should have combined these together, right? Okay, let's see what we get. So 2 times 216, ooh, I might need a calculator. 216 times 2, 12, 1, 3, 4, 432 minus 4W minus, multiply another 2 in there, 4, 6, 864 over W. Let's go ahead and move this 224, or move the 16 to the other. No, move the 224 over here. It's going to end up being quadratic, so let's just move the 224 over. And so 8, 0, and 208 minus 208 equals 0. I can combine the, whoops, did I do that right? Yeah, combine the 432 and the 208. Seems like I screwed something up. Well, I guess we'll find out. So 2, 12, 8, 9, 10, 11, 12, 4, 2, 224. Let's move this junk to the other side so I don't have to deal with negatives. So I ended up having to move it anyways. So what do I get? 864 over W plus 4W. So this has been plus, now it's minus 224 is 0. I'm convinced I made a mistake. I should just get my stupid calculator. No, I'm going to go for it. Let's multiply by W straight through. So 864 plus 4W squared minus 224W is 0. If I divide out by something, let's divide out by 4 and see what we get. So 864 divided by 4, 2, 8, 1, 4, 2, 4, 6, 216. So I have W squared I'm going to go 4 in the 224. So 520, 56. So W squared minus, I think it's 56W. And that's definitely wrong. And then plus the 216 is 0. So it's this 224, which is messing me up. So where is it? 224 is from here, and that would have been the 432 minus the 208. And so maybe here. So I move this over. So maybe the 216. I'm going to have to get my calculator. This is really ticking me off. It might be right. I don't know. Alright, so it's like I'm going to have to redo the whole problem as usual. So I'm sort of looking at my notes trying to figure out where I went wrong. It might be okay. I don't know. Let's forge ahead. What do we have here then? So obviously it has to be W and W. I need two numbers that multiply to be 216, but add to be 56. It's got to be minus and minus. So I would say it's not 54 and 4. It's really close. It's not 36 and 6. It's not 18 and 12. Nine and 24, nope. So something's wrong. I screwed something up in the math here. Let me go back and look. So this is right. This is right. I think. WL minus 4L minus 4W plus 16. And then when I distributed, frick, there it is. It should be 32. Right, so let's carry that down. This is 32. What else? Then I bring over the 224. That'll be 192. Then this thing, 432 minus 192 is 240. And then divided by 4. 60. It still seems like it's wrong. I thought I had it. So 32, 224, bring the 16 times 2 is 32, right? 16. And then Sorry about this. Boy. Well, I didn't distribute any of that stuff. This should be 8. This should be 8. Oh my gosh. All right. Oh, frick. So this is 8. This is 8. This is 8. This is then 2, 2, 1, 6 times 8. 17, 28. This would be 8. This then, when I multiply through by this is the 1728. It's 192, 432. So that should be right now. This is 8. This is 1728. And then I think you could divide by 8. Okay, so this thing should become 17. As soon as my calculator starts working, 1728 divided by 8 is 216 plus w squared minus 240 divided by 8 is 30. And then that's it. Oh my god. So anyways, w squared minus 30w plus 216 is 0. So w, it's 18 and 12 minus 18. W minus 12 is 0. So w equals 18. In that case, L will equal 216 over 18. So just back substituting into this formula here. So 216 over 18 should be 12, which it is. Okay. And then if W is 12, L will be 18. Okay, so either way you slice it, those are going to be the dimensions. 18 by 12 or 12 by 18. Enough of that.